let's graph, or let's learn how to graph the PPF, right? We start, well, how about I tell you what the agenda is today? Today's agenda, we are going to learn how to graph a linear PPF, a bowed-out PPF, shifts in the PPF, such as a parallel shift or an asymmetric shift, and then we will look at points on the PPF. And many of you probably already know this, but again, watch till the end so that you can get a review at best, or maybe learn something new today. Okay, let's do the linear PPF first. With the linear PPF, let's start with some goods. I'm going to keep it simple. How about I just do good X and good Y? So we have good Y on the Y axis and good X, sum product, good X on the X axis. The linear PPF, I'm going to use my ruler here and just draw a linear line, right? And there we go. Now, if I know the quantities, I could write the quantities here. Let's say 300 units of good Y and 200 units of good X. And this is the linear PPF. Simple, right? Good. I'm glad you think so. Next, let's do the bowed-out PPF. The bowed-out PPF, again, we will write good Y here to keep things simple, and good X here to keep it simple. The bowed-out PPF sort of looks pregnant, right? You can't forget that. See, that's how it looks. Again, if I know the units, I will write say 4,000 units of good Y and 3,000 units of good X, and my origin is 0. All right, so that's the bowed-out PPF. That's what it looks like. Now, when you're drawing this, you want to keep your drawing flat at the top here, and then steep as you go down to the right hand side. You keep it steep, right? So it's flat here, and then it turns less flat, and then it gets steep, right? Okay, good. One thing I want us to review when we look at these two PPFs, the linear PPF and the bowed-out PPF, is the slope. Think of the slope. What is the slope of this line? The slope of this line at this point A is the same as the slope of this line at this point B. The slope is the same along the line because it's a linear straight line, you see. So slope here is constant. Now, when you look at the bowed-out PPF, you can sort of guess, when I talked about how to draw it, you can sort of guess what the slopes will be. Now, in case you didn't follow all that, I took a portion of the graph off. In case you didn't follow all that, and I think I know how to do this to bring it back right here, and just make my pixel eraser smaller, and there we go. Beautiful. Okay, using red, think about the slope of this curve. There is a point here, A. The slope at point A there is not the same as the slope at point C over there. And the slope at point C over there is not the same as the slope at point E over here. How do I know that? How I know that is I draw a line that's tangent to that point A. So in red, that's my line tangent to the point A. In red, that's my line tangent to the point C. And in red, that's my line tangent to the point C. And then I take the slope of the tangent lines. The slope here is almost 0. and then the slope here at point C gets bigger, let's say 2, and then the slope at E is super big, super large slope. So what we notice is as you move from the left hand side to the right hand side, the slope increases. That is something you really need to hang on to in the class when we are using PPFs, the bowed-out PPFs, to describe what is happening in, say, an economy. Okay, the slope increases as you move from your left hand side to the right hand side. Now, what if I flip the goods? What if it's good X on the Y axis and good Y on the X axis? Still, as you move from the left hand side to the right hand side, the slope will increase. If you don't believe me, pause and turn this so that good X is on the Y axis, good Y. You can see that the top of the PPF will still be flat. Okay, bowed-out PPF. Let's look at our agenda and see what we have been able to do. Oh, great. Next, we go to shifts in the PPF. Shifts. Let's start with a parallel shift. So in this case, I will draw both the linear and the bowed-out PPF. And so using my ruler and color black, here I have good Y, good X, and just to keep things simple, good Y, good Y, and good X. So here goes my bowed-out PPF. Okay, with the linear PPF, how can we explain a shift in the PPF? Now, the height of the PPF, right, this frontier that we have drawn here, it signifies what our current level of technology and our factors of production can produce in the economy that we are studying, or for the individual that we are studying. The factors of production are cell, physical capital, entrepreneurial ability, land, and labor, plus the level of our technology, right? What those can help us produce, that is what gives us or helps us get to our frontier of production. Now, if our PPF, the frontier, is going to shift outward, then probably that means that our technology got better, or that our labor became more educated, or we have some improvements in our physical capital. Do you see where I'm going with this? Okay, so let's see a shift in the PPF outward. That is a shift outward from the black to the red. In terms of our bowed-out PPF, right, a parallel shift outward will look exactly like this, and for the same reasons the linear one shifted outward. Can we get an inward parallel shift? Oh yeah, we can. In that case, maybe something happened to our labor. Maybe there was a disaster, most of the labor passed on or became incapacitated somehow, or our physical capital was destroyed in a fire. You see where I'm going with this? Okay, let's draw that, an inward shift. An inward shift will look like that, where the black is shifting towards the origin. And in case of the bowed-out PPF, we are going to get one like that. Parallel shifts. And this is due to changes in our cell and in our level of technology. Okay. Shifts in the PPF, asymmetrical shifts. Let's do good Y on the Y axis, good X on the X axis, and draw the PPF with enough space for movement. Okay, so I have both the linear and the bowed-out PPF. A parallel shift means that there will be an outward shift only in one of the goods. So say in good X, there's an outward shift, but not in good Y. What would that look like? That will look, so I'm going to draw this shift in red. That would look like this, exactly what you're thinking of. Oops. Good. That will look like this, and so we get the outward shift in only one good. Similarly, with the bowed-out PPF, the outward shift, I'm going to try my best and hit this. Yep, there we go. The outward shift is only in one good. Cool. So back to the agenda. What have we done so far? We have covered linear PPF, bowed-out, and shifts in the PPF. The next thing we are going to do is points on the PPF. Now I'll use just the linear PPF to show this. So here we start with a linear PPF in black, and we want to show an attainable point A on this PPF. Again, let me label my axis, good Y, good X. An attainable point, can you guess where it will go? Yeah, it will go right on the PPF. An attainable point A will go right on the PPF. An attainable point A can also go inside the PPF. So that tells you an attainable points can be found right on the frontier or within the space that's created by the boundaries of our axis and the frontier. An unattainable point, now I'll show that in red. An unattainable point, point B, is right out here, point B. So the entire space that is outside the PPF will contain unattainable points. Right, so point B is unattainable. Okay, now an efficient point, point C, an efficient point, point C. All the points along the PPF are efficient, right? All the points along the PPF are efficient. And oops, I just wanted to change the color. So point C, all the points along the PPF are efficient. An inefficient point, point D, well, that will be, and I'm running out of color here, I'm going to go back. Oh, I have green. Okay, an inefficient point, point D, will be found within the boundaries of the frontier and the axis. So here we have point D, inefficient. Now think about this inefficient point. What is happening? I told you that with our current technology and our 4 factors of production, we can get to points on the PPF. If we are fully using our factors of production, we get to points that are efficient. If we are not fully using all our factors of production, we are stuck with points that are within the boundaries of the axis and the PPF, like point D, and that is inefficient. That means that possibly a physical capital like a factory is sitting idle, a physical capital like an assembly line is sitting idle, labor, one of our factors of production, is possibly idle. Okay. A trade-off point E. Now, how about I do point E and point V, right? So here we have point E and V. Let's see if I can find more colors. Okay, point E and point V, trade-off. So that's point E and that's point V. The trade-off will look like that. Now, to better illustrate this, how about I draw a new let's illustrate this separately from all the color. That way you can see what it is that I'm doing and better understand that good Y, good X, and then I have my linear PPF right here. Okay, oops. Origin 0. We are looking at a trade-off point or 2 trade-off points, E and V. We need 2 to show this is point E and this is point V. What is happening at point E? Let me show you what is happening at point E. Say we have 50 units of good Y and 20 units of good X at point V. If we want more of good X, we are going to want to move in this direction. But as we get more of good X, we have to give up some of good Y. And so if you want more of good X, you're going to get here where you have 10 more units of good X that gets us up to 30, and 10 less units of good Y. Do you see that? That is a trade-off. To go from point E to point V, you have to give up some of good Y to get more of good X. That's what that means. That's the trade-off. Now, what about a free lunch? What is a free lunch? Again, I will draw a separate graph to show us what a free lunch is so that you are not focusing on all these other points here. And pardon me if this is still crooked in spite of my ruler. All right, so we have here good Y and good X. Okay, and we have our linear PPF and we want to show a free lunch. A free lunch, you're trying to go from one point to the other, but not give up any units of the other good. So say you want more of good X. So you're going to get more of good X without giving up any of good Y. So free lunches start, you can start here. A free lunch, or to illustrate a free lunch, you can start from the inside. Now, where are you going to go? Well, or let's start with what do we have at that free lunch point. Did I make a note of what my free lunch point F? Let's say F and G, right? F and G. Okay. So free lunch point F and G. So let's put F. Let's call that F. And at F we have 15 units of good Y, 20 units of good X. So let's say you want more of good X, but you don't want to give up any of good Y. You must be starting from an inefficient point though. Okay? So using red, let's show you what that free lunch path is going to be. It will have to get more of good X, but not give up any good Y. And I'll write that for you shortly. From F to point G, right? This is the free lunch path. F to G. You want more of good X. So how much more of good X did we get? I'm gonna use black now. We got 30 more units of good X, but we didn't give up any good Y in our path from F to G. Right? So this red path is the free lunch path. The free lunch path. Can we show another free lunch path? Sure, we can. So let's call this G1. Another free lunch path. So free lunch path F to G1, right? Let me write that all before you, so you don't forget. Free lunch path F to G1, we want more of good X, but not give up any good Y. Right? So you start from an inefficient point F and straight to the right onto the frontier. Is there another free lunch path? Yes, there is another free lunch path. Let me show you. Some of you can already guess. I'm going to show that in blue. See why I had to get away from all the points? Yeah. All right. Another free lunch path will be the path where we want more of good Y, but we don't want to give up any of good X. Starting from point F. All right. So here is the next free lunch path, or the other free lunch path, to G2. Right? So here, free lunch path F to G2. We want more of good Y, but not give up any good X in the process. Let's go back one step. Here we learned about the trade-off, that to get more of one good, you have to give up the other one, right? Trade-off path E to V. Trade-off path E to V. You want more, we want more of good X. Pardon me, excuse me. We want more of good X. So we give up some of good Y. So we got more of good X by giving up some of good Y. That is the trade-off path. That was the trade-off path that we just saw in trade-off. With a free lunch, it's a little different. And hopefully you can see the red that's showing the path, the free lunch path from F to G1. we want more of good X, but not give up any of good Y.